Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video we are discussing about inverse of a matrix, means definition of inverse of a matrix and some method to find out inverse of a given square matrix. So if you are new on my channel, subscribe the channel and hit the bell icon to get notification of every newly uploaded videos. Well, now try to understand what is the meaning of inverse of a matrix. Let us suppose that two matrices are there. A and B are what? Two matrices of same order, square matrices of same order. If A and B are two square matrices of same order, such that their multiplication is what? Identity matrix. So when we can say that matrix are square matrix if number of rows and number of columns are what? Equal, and order of these two matrices should be what? Same. Means if A and B are two square matrices of same order, but they satisfy which condition? Their product, means their multiplication is what? Identity matrix. If this condition is satisfying, at that time only we can say that this A and B are what? Inverse of each other. Hope the idea about definition of inverse of a square matrix is clear to you. अगर दो स्क्वायर मैट्रिसेस का मल्टीप्लिकेशन आइडेंटिटी मैट्रिक्स आता है तो हम ये दोनों मैट्रिक्स को एक दूसरे के इनवर्स कहते हैं. मींस these A and B are what? Inverse of each other. These two matrices are inverse of each other. This condition is not satisfying in every case, but in case if this condition is satisfying that their multiplication is identity matrix, then these two matrices are called as inverse of each other. Now inverse of matrix A is denoted by this notation, A raised to power minus 1. This notation is used for what? A inverse, isn't it? So I hope the idea about symbolical representation of A inverse is clear to you. If A is a square matrix, then its inverse is denoted by this notation, A raised to power minus 1, but A raised to power minus 1 can be read as what? A inverse. Okay. Now just now we have seen that multiplication of these two matrices is identity, then A is called as inverse of B and B is called as what? Inverse of A. Means inverse of A is what? B. So inverse of A is B and inverse of B is what? A. A and B are inverse of each other. Means a value of A inverse is B and B inverse is what? A, according to our definition. Now if I am substituting this value of B in this expression, replace B by what? A inverse. So what we will get here? A into A inverse is equal to I, because I am replacing B can be replaced by what? A inverse. So A keep it as it is, but replace B by its value A inverse. On this side I keep it as it is. Means what important expression we are getting here? Multiplication of matrix with its inverse is what? Identity matrix. In the same way, if we are replacing this A by B inverse, चलो ये A के जगह पे B inverse अगर substitute किया तो क्या मिलेगा हमें? B inverse into B is equal to I. Just simply we are substituting this value in this expression, so we will get this important result that A and its inverse, multiplication of A and its inverse is identity. In the same way, multiplication of B inverse and B is also what? Identity. Now we are discussing some important method to find out inverse of a matrix. अगर एक मैट्रिक्स दिया है हमें, अगर A मैट्रिक्स दिया है, उसका इनवर्स फाइंड करना बोले तो ऐसा एक नया मैट्रिक्स ढूंढ के निकालना है हमें कि जिसके साथ A का मल्टीप्लिकेशन अगर लिया तो रिजल्ट क्या आना चाहिए? आइडेंटिटी आना चाहिए. मीन्स इफ वन मैट्रिक्स इज गिवन टू अस, वी आर फाइंडिंग सच न्यू मैट्रिक्स दैट द multiplication of new matrix with the given matrix should be what? Identity, isn't it? So well, so first method to find out inverse of a matrix is by adjoint method. Now question can be asked that find the inverse of a matrix using adjoint method or using row transformation or using what? Column transformation. Getting it? So first we are discussing how to find out inverse of a matrix by adjoint method. So in this case some steps are there to find out inverse of a matrix by adjoint method. So first step, whatever maybe the matrix is given to us, find out its determinant. Then second step, find out the cofactor of all the element of that matrix. Third, once the cofactor is known to us, collect all these cofactor in a matrix which is called as what? Matrix of cofactor. How to find out matrix of cofactor and adjoint, that already we have discussed in the last video. Once the matrix of cofactor is known to us, taking its inverse, we are able to find out adjoint. Once determinant and adjoint is known to us, so this formula is applicable to find out A inverse. What is the formula? A inverse is equal to 1 upon determinant of A into adjoint of A. Adjoint of A is a matrix and determinant of matrix means what? One number. So here whatever will be the value of determinant, we are getting, substitute here the value of determinant and here write down the matrix which you are getting in step 4, that is adjoint of a matrix. So applying this formula we are able to find out inverse of a matrix. Again, if you observe this formula, to apply this formula two values are required. One is determinant, so first we are finding determinant, and second required value is what? Adjoint. And how to find out adjoint of a matrix? To find out adjoint, first find out cofactors of all element, then second step is collect all these cofactor in a matrix which is called as matrix of cofactor, and later on taking transpose of this matrix of cofactor we will get adjoint. अगर ये दो वैल्यू मालूम हो गए तो ये दोनों भी वैल्यू इस फॉर्मूले में सब्स्टिट्यूट करना है to find out what? Inverse of a matrix. So this is the method to find out inverse of a matrix, applying adjoint method. Now let us see how to find out inverse of a matrix by row transformation method. So already we have seen that A into A inverse is equals to what? Identity matrix. So this condition we are applying in case of row transformation, getting it? And in case of column transformation, just we are interchanging these two terms. A inverse into A is equals to I. Whenever we are taking multiplication of two matrices A and B, then A is called as prefactor and B is called as what? Post factor. Row transformation में क्या होता है कि ये पोस्ट फैक्टर कांस्टेंट रहता है, इसलिए हमने A इनवर्स कहाँ पे लिया? पोस्ट फैक्टर पे ले लिया, बिकॉज वी हैव टू फाइंड आउट वैल्यू ऑफ A इनवर्स. वो डिस्टर्ब नहीं होना चाहिए, उसकी तो हमें वैल्यू निकालनी है. सो दैट्स व्हाई A इनवर्स शुड बी पोस्ट फैक्टर. एंड इन केस ऑफ कॉलम ट्रांसफॉर्मेशन, whatever may be the operation we are performing, so should be on matrix A. Means since we have to find out value of A inverse, in case of column transformation, prefactor is constant, means its value does not changes, it remains constant. और हमें फाइंड क्या करना है? A inverse, इसलिए हमने prefactor क्या लिया? A inverse. Means रो ट्रांसफॉर्मेशन में पोस्ट फैक्टर कांस्टेंट रहता है और कॉलम ट्रांसफॉर्मेशन में प्रीफैक्टर कांस्टेंट होता है. कांस्टेंट होता है यानी इसकी उसको चेंज नहीं करना है. जो भी हम रो ट्रांसफॉर्मेशन के ऑपरेशन करेंगे, मींस वी आर परफॉर्मिंग 3 एलिमेंट्री ट्रांसफॉर्मेशन ऑपरेशन. ऑलरेडी वी हैव सीन व्हाट आर द 3 एलिमेंट्री ट्रांसफॉर्मेशन ऑपरेशन, and applying this operation we have solved example from first exercise also. So here we are applying these operations on what? Row. अगर ये हमने रो पे अप्लाई किया तो चेंजेस किस में होंगे? A में और ये साइड में I में. So what is our aim? Whatever may be the matrix A is given to us. Let us suppose that its order is what? 2 by 2. Our aim is to convert this matrix A into what? Identity matrix. अगर ये matrix identity हो गया तो identity into A inverse आता है. Means if you are multiplying by identity matrix to any matrix, we will get the same matrix. Means if you are multiplying by identity matrix to A inverse, we will get what? A inverse. And our aim is also to find out value of what? A inverse. Means on this side we are trying to convert matrix A into what? Identity matrix. And these are the element of identity matrix. Whatever may be the operations of row transformation we are performing on matrix A to convert it into what? Identity. Same operation we have to perform on this side also on identity matrix. And if we are performing some operation on this matrix, the element of this matrix will get changed. So on this side we are getting new matrix. And if we are able to convert this matrix into identity, so identity into A inverse, on this side we will get A inverse, and on this side we will get one new matrix, and that new matrix is nothing but value of what? A inverse. अगर ये matrix identity हो गया तो identity into A inverse क्या मिलेगा? A inverse. Means इस साइड में A inverse मिलेगा हमें, और ये साइड में एक नया मैट्रिक्स मिलेगा, and that new matrix is nothing but value of what? A inverse, isn't it? Now whenever we are converting this matrix into identity matrix, so we have to follow some steps. क्यों फॉलो करना है ये भी आपको समझ में आएगा. सबसे पहली स्टेप है कि यहाँ पे हमें पहले 1 लाना है. दिस इज आवर व्हाट? फर्स्ट स्टेप. यहाँ पे क्या लाना है? 1. एक बार यहाँ पे 1 मिल गया तो सेकंड स्टेप यहाँ पे 0 लाना है. यहाँ पे क्या लाना है? 0. दिस इज द सेकंड स्टेप. थर्ड स्टेप यहाँ पे 1 लाना है. यहाँ पे क्या लाना है? 1. दिस इज व्हाट? आवर थर्ड स्टेप. और लास्ट में यहाँ पे क्या लाना है आपको 0. दिस इज आवर फोर्थ स्टेप. गेटिंग इट? So these are some steps we have to follow to convert this matrix A into what? Identity matrix. यहाँ पे कुछ अलग एलिमेंट होंगे, तो यहाँ पे सबसे पहले हमें एलिमेंट्री ट्रांसफॉर्मेशन का यूटिलाइज करके 1 लाना है, फिर यहाँ पे 0 ये हो गई हमारी सेकंड स्टेप, यहाँ पे 1 ये हो गई हमारी थर्ड स्टेप, और यहाँ पे 0 ये हो गई हमारी फोर्थ स्टेप. इन दिस वे वी हैव टू कन्वर्ट द मैट्रिक्स A into what? Identity matrix. Whatever may be the operation we are performing on this matrix to convert it into identity matrix, same operation we have to perform on I also, so that on this side we will get a new matrix which is our required inverse of the given matrix. Okay, this method, how to apply this method, definitely we will discuss while solving the example also. Now in case if the matrix is of order 3 by 3, at that time 9 elements are there and we have to convert this matrix into what? Identity matrix to find out inverse. तो यहाँ पे कुछ स्टेप याद रखो आप, ये 3 एलिमेंट मिलने चाहिए, पहले 1, बाद में 0, बाद में 0. सो दिस इज आवर फर्स्ट स्टेप. ओके, तो अभी मैं बहुत सारे स्टेप्स में इसे डिवाइड नहीं कर रहा हूँ. सो सबसे पहले ये फर्स्ट स्टेप, ये सेकंड स्टेप, ये थर्ड स्टेप. इसके अलावा हम सिर्फ ये कॉलम को, फर्स्ट कॉलम को 1 0 0 करना है. Consider this is our first step. Once we have got 1 0 0, then try to get this element, isn't it? Try to get these element, यानी यहाँ पे 1 0 0 1 ये मिलने चाहिए. दिस इज आवर सेकेंड स्टेप. एक बार ये एलिमेंट मिल गए, देन थर्ड स्टेप इज टू गेट व्हाट? 0 0 हियर. सो दिस इज आवर थर्ड स्टेप. यहाँ पे 0 0 लाने की कोशिश करना है. सो व्हाट इज फर्स्ट स्टेप? फर्स्ट स्टेप, गेट दिस एलिमेंट 1 0 0 मीन्स कन्वर्ट फर्स्ट कॉलम इनटू 1 0 0. देन सेकंड स्टेप इज टू गेट 1 0 0 1. हो सकता है ये 4 एलिमेंट मिलने के लिए आपको 2-3 रो ट्रांसफॉर्मेशन के ऑपरेशन यूटिलाइज करने पड़े, और लास्ट में आपको यहाँ पे 1 0 लाना है. If we are following these steps, then the element which we have got will not disturb. इसका मतलब क्या हुआ? आपने यहाँ पे 0 लाया, यहाँ पे कुछ अलग एलिमेंट होगा और आपने कुछ ऑपरेशन करके यहाँ पे 0 लाया, फिर ये एलिमेंट 1 लाने के लिए जो ऑपरेशन हम यहाँ पे करेंगे उसकी वजह से ये एलिमेंट डिस्टर्ब नहीं होना चाहिए. नहीं तो क्या होगा, ये मिल गया तो फिर इधर का एलिमेंट लाने के लिए ये डिस्टर्ब हो जाएगा, फिर इसको 0 करने के लिए और कोई एलिमेंट डिस्टर्ब हो जाएगा. तो ये नहीं होना चाहिए, इसलिए हमें क्या करना है? ये स्टेप्स फॉलो करना है. मीन्स टोटल 9 एलिमेंट्स आर देयर, वी हैव टू कन्वर्ट देम इन दिस फॉर्म. तो जो आपको एलिमेंट मिले हैं रो ट्रांसफॉर्मेशन अप्लाई करके, वो डिस्टर्ब नहीं होने चाहिए. दैट्स व्हाई वी हैव टू फॉलो दिस स्टेप. एंड इफ यू आर यूजिंग दिस स्टेप्स, then definitely the element which we have got will not get disturbed. अगर ये steps अगर आप follow नहीं करते तो यहाँ पे 0 आ गया, तो फिर यहाँ का 0 लाने के लिए ये डिस्टर्ब हो जाएगा और ये मिलने के लिए और कोई डिस्टर्ब हो जाएगा. तो यही काम नहीं करना है हमें. So that's why we are following this step, so that the element which we have got will not get disturbed. Hope the ideas are very clear to you. Now in case of column transformation, so you have to remember that in case of row transformation, A into A inverse is identity, we have to use this condition. In case of column transformation, A inverse into A is equal to identity. In this case, A inverse remains constant. Whatever may be the changes will happen in matrix A and identity. तो ये यहाँ पे भी हमारा aim क्या है? ये A matrix को identity में convert करना है. And once it becomes identity, then identity into A inverse will be A inverse. On this side we'll get A inverse. And whatever may be the new matrix we are getting on this side will be the value of A inverse. Means our aim is to convert it into identity matrix. So let us suppose that this is the given matrix A. Whenever we are converting it into identity matrix, this will be our first step. तो फर्स्ट स्टेप में यहाँ पे फर्स्ट स्टेप क्या था? ये फर्स्ट स्टेप था. तो यहाँ पे ये फर्स्ट स्टेप है. फर्स्ट रो में 1 0 लाना है. देन दिस विल बी द सेकेंड स्टेप. यहाँ पे 1 लाना है, ये सेकेंड स्टेप, और लास्ट में यहाँ पे 0 लाना है. ये हो गई हमारी थर्ड स्टेप. सेम स्टेप्स वी हैव टू फॉलो इन केस ऑफ matrix if its order is 3 by 3. So what is our first step? First step is to get 1 0 0. Again remember, in case of row transformation, यहाँ पे column 1 0 0 ये पहली step है. यहाँ पे row 1 0 0 आना चाहिए. This is our first step, and this is the second step, and this is what? Third step. Okay, Using this step, if we are solving the example, so easily we are able to solve the example, and even the element which you have got by performing row transformation or column transformation will not get disturbed. So using this method, now we are solving the example from the next exercise. Now see the question number 5 from exercise 2.2. In this case, some matrices are given to us and we have to find out inverse of a matrix using adjoint method. So already we have seen 5 steps are there to find out inverse of a matrix by adjoint method. What is the first step? First step is to find out determinant of that matrix. So let us try to find out determinant of this matrix. Determinant is denoted by this notation. This notation says that we are finding determinant of which matrix? A. Whenever we are finding determinant, write down all the element of a matrix in vertical segment, which is the symbol of what? Determinant. So write down all the element. In case of square bracket, write down all these element in what? Vertical segment, means it represent that we are finding determinant of this matrix. So whenever we are finding determinant, first take the product of diagonal element, which is -2, minus, then take the product of off diagonal element, that is -15. So minus and this minus will become +15 is equal to 15 minus 2 is equal to 13. Once the value of determinant is known to us, then our aim is to find out adjoint. But to find out adjoint, what is our second step? We have to find out cofactor of all the element. So find out cofactors. So cofactors of elements are. So cofactor of first element is denoted by A11, second element by A12, third element means this element by A21 because it lies in second row and third column, and lastly cofactor of element which lies in second row, second column. Let us try to find out cofactor of all these 4 elements. What is the formula? -1 raised to power I plus j, means 1 plus 1 into m11. So here what will get? -1 raised to power 1 plus 2 into m12. Here what we will get? -1 raised to power 2 plus 1 into m21. Here we will get -1 raised to power 2 plus 2 into m22. Okay, so just we are applying the formula of cofactor, how to find out cofactor of the element. So let us simplify it. Here power of -1 is even number, so its value is +1. Here odd number, so its value is -1. Here power of -1 is odd number, so its value is -1. Here even number, so its value is +1. Remaining part is just to find out minor. To find out value of minor, we have to delete element of first row and first column. So delete element of first row, first column, what we are getting here? 2. Again we know that value of minor is determinant, and to obtain the element of this determinant, delete first row, second column. First row, second column, what we will get here? -3. Now delete second row, first column. Second row, first column, we will get 5. And here delete element of second row and second column, what we will get? -1. So 2 into 1 will be equals to 2. -3 into -1 will be +3, because value of determinant, if it contain only one number, then same number will be the value of that determinant. So value of this determinant is 5. 5 into -1 is -5, and here -1 into 1 will be equal to -1. Once the cofactors are known to us, collect all these cofactor in one matrix, so which is called as matrix of cofactor. So therefore matrix of cofactor is, so collect all these cofactor in one matrix. What we will get? 2, 3, -5 and -1. Once the matrix of cofactor is known to us, we are able to find out adjoint of a matrix. We know that adjoint of a matrix is nothing but matrix of transpose of matrix of cofactor. Means how to take the transpose of matrix of cofactor? Simply interchange rows and column, means convert first row into first column. So 2, 3, convert second row into second column, -5, -1. In this way we have got adjoint. Once all these values are known to us, what is the last step? Fifth step is to find out A inverse. And what is the formula to find out A inverse? 1 upon determinant of A into adjoint of A. So which is equal to 1 upon, what is the value of determinant? That is equal to 13, and element of adjoint of a matrix. To check whether our answer is correct or not, check that these two elements are get interchange or not. Yes, these two elements will get interchange, and check that sign of these two elements will get change or not. Here plus 5 is there, so here its sign changes -5. यहाँ पे -3 है तो यहाँ पे +3 है. Means we can say that our answer is what? Correct. Already we have written this condition as a note also, how to tally whether our answer is correct or not. Now write down the adjoint. This is adjoint of matrix A, minus its elements are 2, -5, 3, -1. In this way we have got inverse of a matrix using which method? Adjoint method. Again, try to understand what is first step to find out determinant. Second step is to find out cofactor of all the element. Third step is to write down matrix of cofactor. Once the matrix of cofactor is known to us, then fourth step is to find out its adjoint by taking transpose of this matrix. Once adjoint is known to us, substitute the values in this formula, you will get your required matrix, which is nothing but inverse of the given matrix. Now observe the second example. In this case also, in the second example, matrix is of order 2 by 2. Exactly same method we have to use here, which we have seen in the last example. So let us denote the given matrix by matrix A. Now first step is to find out determinant of this matrix. So write down all these elements of this matrix in determinant. So let us simplify it. 6 minus this product is -8, minus and this minus will become +8 is equal to 14. 6 plus 8 is 14. In this way we have got the value of determinant. Now let us try to find out cofactor. Already the formulas are written here, remaining part is just to substitute the values, and already in the last example we have got here how we have got +1, -1, -1, +1, which is nothing but value of this first term in this formula. Now minor is determinant. To obtain the element of this determinant, delete first row, first column, we will get 3. Now delete first row, second column, we will get 4. Delete second row, first column, we will get here -2. Delete second row, second column, so here we will get 2. So 3 into 1 will be equal to 3. 4 into -1 is -4. -2 into -1 is +2, and 2 into 1 is 2. In this way we have got the cofactor of all the element. Once the cofactor is known to us, collect all these cofactor in one matrix. 3, -4, 2, 2. So this matrix is called as matrix of cofactor, and taking its transpose we will get adjoint. Take the transpose, convert first row into first column. 3 -4, convert second row into second column. चलो देखो अब अपना आंसर करेक्ट है या नहीं. क्या देखना है आपको? ये दो एलिमेंट इंटरचेंज होने चाहिए. सो वी कैन ऑब्जर्व दैट दीज टू एलिमेंट आर इंटरचेंज, और ये दो एलिमेंट का साइन चेंज होना चाहिए. यहाँ पे -2 है तो यहाँ पे +2 होना चाहिए. यस, वी हैव गॉट +2. यहाँ पे +4 है तो यहाँ पे -4 होना चाहिए, और वहाँ पे -4 भी मिला है हमें. मीन्स वी कैन से दैट आवर कैलकुलेशंस आर करेक्ट हियर. Now only the remaining part is substitute the value in this formula to get our required answer, means get our required matrix A inverse. What is the value of determinant? That is equal to 14. Now adjoint, these are the element of adjoint of this matrix. 3, 2, -4, 2. In this way we have got inverse of a matrix. Means if you are taking the multiplication of this A inverse with this matrix, definitely your answer will be what? Identity matrix. Means finding inverse means what? Find out such a new matrix that product of these two matrices will be equal to what? Identity matrix. And one of the method to find out A inverse is adjoint method. Now see the example number 3rd. In this case matrix is of order 3 by 3. Now since we are solving the example using adjoint method, so first step is to find out what? Determinant of this matrix. So let us try to find out determinant. So which is equal to, here first write down 1, then delete the element of first row and first column, find out determinant of these element. So determinant of these 4 element, observe here this product is -3, -0 means -3. Then here 0 into any term is 0. Again 0 into any term is 0, means what result we are getting? 1 into -3 is -3, because first term is 0. If we are deleting this row and column, find out the determinant of these 4 element, but 0 into any number is what? 0. That's why not necessary to simplify it. In this way we will get second term also 0, and here also 0 is there, so that's why third term is also 0. In this way we have completed first step, means to find out determinant. Now second step is to find out what? Cofactor. Already you know what is the formula to find out cofactor, and how to find out cofactor of all the element. So already here we have written that cofactors of all these 9 elements. Only the remaining part is to substitute the values and complete the calculation part. So formula is already written here. Here power of -1 is even number, so here +1. Already we have discussed that in case of 3 by 3, what is the value of first term? +1, -1. Why we are getting such type of term? Because in first case power is even, then odd, even odd, even odd, continuing this way. Here we have got +1, so here we will get -1, here we will get +1, -1 मिलेगा, यहाँ पे +1 मिलेगा, क्योंकि यहाँ पे पावर इवन है. एंड वेन एवर द पावर ऑफ -1 इज इवन, एट दैट टाइम इट्स वैल्यू इज +1. अगर ऑड पावर है तो उसकी वैल्यू क्या होंगी? -1. Now value of first term is known to us. Now we are finding value of minor, and we know that minor is nothing but determinant. And to obtain the value of determinant, delete first row first column. First row first column अगर delete किया तो क्या मिलेगा हमें? यहाँ पे 3 0 2 -1. Now here delete first row second column, 3 0 5 -1, 3 0 5 -1. Then delete first row third column, 3 3 5 2, 3 3 5 2. Now delete second row first column, 0 0 2 0 0 2 -1, 0 0 2 -1. Now delete second row second column, 1 0 5 -1, 1 0 5 -1. Now delete the element of second row and third column. Observe the given matrix. Delete second row third column. Second row third column, 1 0 5 2, 1 0 5 2. Now delete third row and first column. Third row first column, 0 0 3 0. Now delete third row second column. Third row second column, 1 0 3 0, 1 0 3 0. Now delete third row and third column. Third row and third column, 1 0 3 3, 1 0 3 3. Now find out the values of this determinant and complete the calculation part. So here this product is -3 -3 -0 is -3 -3 into 1 is -3. Here -3 -0 is -3 -3 into -1 is +3. Here 6 minus 15. This product is 6. This product is 15. 6 minus 15 is -9. -9 into 1 is -9. Then 0 minus 0 is 0, and 0 into any term is 0. -1 minus 0 is -1. -1 into 1 will be equal to -1. Now simplify this determinant. 2 minus 0 is 2. 2 into -1 is -2. 0 minus 0 is 0. 0 into any term is 0. 0 minus 0 is 0. 0 into any number is 0. 3 minus 0 is 3. 3 into 1 is 3. In this way, we have got cofactor of all the elements. Once the cofactor of all the elements are known to us, then write down matrix of cofactor. Collect all these cofactor in one matrix. -3, 3, -9, 0, -1, -2, 0, 0, 3. Once the matrix of cofactor is known to us, then find out adjoint of this matrix. Adjoint of matrix A is equals to, and we know that how to find out adjoint of a matrix. Whenever we are finding adjoint of a matrix, we are taking transpose of matrix of cofactor. So convert first row into first column, -3, 3, -9. Convert second row into second column, 0, -1, -2. Then convert third row into third column, 0, 0, 3. In this way, we have got adjoint of a matrix. Now last step is to find out inverse of this matrix. And what is the formula to find out A inverse? So A inverse is equal to 1 upon determinant of A into adjoint of A. All the values are known to us, just we are substituting the value. What is the value of determinant? Determinant is equal to -3. Now write down matrix of adjoint of A. So already this adjoint of matrix A is known to us. Its elements are -3 0 0, 3 -1 0, -9 -2 3. So therefore A inverse is equal to, already the value of A inverse is known to us, this value is what, A inverse. लेकिन बाहर नेगेटिव नंबर है और नेगेटिव नंबर अगर आपको अच्छा नहीं लगता होगा, so to replace this minus we are multiplying by this minus to all the element in this matrix. So here remaining term will be what, 1 by 3. Just I am multiplying by this minus to all the element. If we are multiplying by minus means sign of all the element will get changed, means what result we will get here, 3 0 0 minus 3 plus 1 0 9 2 minus 3. Only the change the sign of all the element because we are multiplying by minus to all the element. In this way we have got the inverse of the square matrix of order 3 by 3. Here we can observe that all the element above these diagonal elements are 0, means this matrix is what, lower triangular matrix, and we can observe that inverse of lower triangular matrix is also what, lower triangular, because this is the value of A inverse, and here we can observe that all the element above the diagonal elements are 0, so means this is what, lower triangular matrix. Means what important result we are getting, inverse of lower triangular matrix is lower triangular matrix. Now see the example number 4th. Here also we can observe that the matrix is what, upper triangular matrix, because all the element below the diagonal elements are 0. Means in short we are finding inverse of a upper triangular matrix, isn't it? In case of upper triangular matrix or lower triangular matrix or diagonal matrix, just simply remember that value of determinant is product of diagonal element. 1 into 2 into 5 will be equal to 10. Directly we are able to find out the value of determinant using this method, using shortcut method. If the matrix is upper triangular or what, lower triangular, then product of, or it is diagonal matrix or it is scalar matrix. At that time value of determinant is product of diagonal element, means this product is 10. But this method we are able to use while solving objective type question. Now here let us try to find out our regular method to find out value of this determinant. 1, keep it as it is, delete this first row and first column. Try to find out determinant of these 4 elements. 10 minus 4 will be equals to 10. Then here plus 2 is there, so we are taking minus 2. So delete this row and this column. Take the determinant of these 4 elements. 0 minus 0 will be equal to 0. Lastly 3 into, delete this row and this column. Find out determinant of these 4 elements. Here also 0 minus 0 will be equal to 0. So these two terms will become 0 and 10 into 1 will be equal to what, 10. Now to find out the value of minor, already all the things are written here to save our time. Value of first term is also calculated, only the remaining part is to find out value of minor. To obtain the element of this determinant, delete first row, first column. So 2 4 0 5. Now delete first row and second column, 0 0 4 5. 0 0 4 5. Delete first row and third column, 0 2 0 0 0 2 0 0. Now delete second row first column, 2 3 0 5 2 3 0 5. Now delete second row and second column, second row second column, 1 3 0 5 1 3 0 5. Now delete the element of second row and third column, second row third column, 1 2 0 0 are the element of this determinant. Then delete third row first column, 2 3 2 4 2 3 2 4. Now delete third row second column, 1 3 0 4 1 3 0 4. Delete third row third column, third row third column, 1 2 0 2 1 2 0 2 are the element of this determinant. Now simplify this determinant. 10 minus 0 is 10. 10 into 1 will be equal to 10. 0 minus 0 is 0. 0 into any term is 0. 0 minus 0 is 0. 0 into any number is 0. 10 minus 0 is 10. 10 into minus 1 is minus 10. 5 minus 0 is 5. 5 into 1 will be equal to 5. Here 0 minus 0 is 0. So here we will get 0. 8 minus 6 will be equals to 2. 2 into 1 will be equal to 2. 4 minus 0 is 4. 4 into minus 1 is minus 4. Here 2 minus 0 is 2. 2 into 1 is 2. Once the cofactor of all the elements are known to us, collect all these cofactor in this matrix. So 10, 0, 0, minus 10, 5, 0, 2, minus 4, 2. Once the matrix of cofactor is known to us, take its transpose to find out adjoint. So while taking transpose, convert row into column. So 10, 0, 0. We have converted first row into first column. Then convert second row into second column. Minus 10, 5, 0. Convert third row into third column. 2, minus 4, 2. Once the adjoint of a matrix is known to us, then apply this formula to find out inverse of a matrix. So now substitute the value of determinant. What is the value of determinant? Determinant is equal to 10 into adjoint of a matrix, where element of adjoint of a matrix are 10, minus 10, 2, 0, 5, minus 4, 0, 0, 2. In this way we have got adjoint of this matrix. So we have completed all the 4 examples from this question number 5. In this question we have seen how to find out inverse of a matrix of order 2 by 2 and 3 by 3 using adjoint method. In this way we have completed all the 4 examples from question number 5. In the next video we are solving the question number 6. Example from question number 6 are related with inverse of a matrix using elementary transformation method. So this part we are discussing in the next lecture. So if you like the video, subscribe the channel and hit the bell icon to get the notification of every newly uploaded videos, and even share these videos with your friends also.